Everybody, my name is Sabine Brunswicker. I'm here a professor at Purdue University. I'm also the director of the Research Center for Open Digital Innovation, and I'm so excited that I can present to you now the IronHacks platform. While I'm excited, I'm also sad that I cannot be there in person at the workshop, but I'm glad that I can virtually participate despite the time difference. This Collaboratorium, very difficult to pronounce, really wants to discuss the way forward and how to do research on collectives and groups. And I think that's so important. And over the last years, my team here at our Cody have been building a Kaggle-style platform that allows realistic experiments on collectives and groups, and I would like to introduce you to it. And we've gone through the struggles, and we are at a stage where we really invite others to use it and work with us to further improve it, run experiments with it over time. Yeah, now let me jump into the agenda. I would like to give you an overview of what IronHacks is, a Kaggle-style platform for randomized experiments in the cloud with realistic task settings. A bit of history, its key features, and its platform architecture. Then I'm going to show two examples of a task. It's actually one example, but one example related to information disclosure and transparency, because that has been the primary focus of our research in the past. Reason why is the following. We have been supported at the beginning of this journey as we started to develop IronHacks by an NSF grant, and that grant was focused specifically on information disclosure transparency in innovation contest or kind of collective innovation processes. We adopt in our research a search view. We think about innovation being a problem-solving process where individuals search in the context of a group, and it depends on how they interact. We do not have coordinations at this point. We don't study kind of an collaborative group setting, and that also the action are all coordinated, so it's a collective or a crowd setting with our group, but you could technically do that in the platform. And then at the end, I'm also going to talk about the features for and benefits for research or admins. I would like to then conclude with a demo, and will demo myself, and if that doesn't work, I'm just going to share afterwards with you a pre-recorded demonstration that my team did just today for you just on the platform. So IronHacks has been developed by my research center here at Purdue University, which I founded when I came to Purdue 2014, and we designed technology and studied the effect on group and collectives, and specifically a focus on digital platforms. And in case you know my publication, digital platforms have a core focus, but IronHacks is really about studying innovation in collectives and groups. If you want to know about the center, there's also a website. So IronHacks is a Kaggle-style platform at this point of time, but there are other platforms that have been used by existing researchers to study innovation, and since these platforms offer a new way to hack data or hack technical computational programs and to explore uncovered solutions or finding ground truth, companies rely on those, but also researchers rely on those. And I've seen a lot of paper these days that have used Topcoder was heavily used, for example, for a while, as you might know from some. Published highly, and then now we see Kaggle coming around as well. So that has been our focus, but it has evolved over time. I would like to kind of classify in the beginning the platform itself with respect to the decision tree that was shared prior to that workshop. And I want to mention that our IronHacks platform offers flexibility in terms of the attributes, in terms of timing of the actions, whether it's contemporaneous or asynchronous. The timing, the actions, whether independent or dependent, the incentives, whether they're independent and dependent, I would say at this point we are more on the asynchronous side. On the action side, you're more independent, but I would say it's more like an oscillating process. We look into socially moderated effects quite a lot because we focus on information disclosure that is collective information. The incentives at this point are independent, but we actually run one group experiment as a pilot. It's possible to do that, and the communication is possible at this point. People can add it. We've used it, but not necessarily been a key focus. Rather, we use it to kind of control for, so that we know what's going on in case we knew that people participate in from the same context, from the same school, etc., so that we kind of provide the rule and only communicate via the platform, and we have that. So the software is designed in a flexible way to support that. So I want to also mention that the platform design has evolved over time. We started with this quite early, I think it was 2015-16, and there we focused on web app development, mesh apps, where they had to design interactive web apps. Basically there the people searched visual and code landscapes. We'll talk about this a little more. The tasks were more wicked, more uncertain. Evaluation was more multiple dimension because it was more a visualization task. We worked at experts ratings. The skills were slightly different. It was web design, HTML, CSS, etc. It was always a virtual problem-solving space, fully integrated. Communication was supported at this point. For was there, and the architecture was different. We shifted towards data science and machine learning over time. We could still do web apps, but our focus has been really on the integration of data science tools, because data science is a very interesting innovation setting, because there you need to work with realistic data to actually do data science and machine learning. So it's a very unique setting, and it's also transforming, I would say, the real world, but at the same time also an interesting setting to study, because you often have ground truth data and you basically know the peak in the landscape, and you can control the solution space by controlling what functions or libraries or etc. they can use, because you can actually modify that all. Landscapes here, as we used it, code summary is visual. I'll talk more about it. As I mentioned, you have ground truth. There is no, at this point, expert evaluation needed. We score everything at this point computationally. Then also the skill set of the participant has changed to Python. We focus more on Python, but you could also use R, Julia, and SQL. You could still do web design challenge if you want to, but it's not necessarily what we at this point have fully integrated through the add-on features. Yeah, and also the platform has shifted to another architecture. In the past, we primarily focused on societal challenge just because of the unit setting that we had, and also it gives us a kind of a particular setting, like an indirect motivational incentive for people to participate in addition to prize money. We had about more than 2,000 participants in the past participating. Not all of them were used for research. The research were also used for sometimes for learning, but the data is there also still to be analyzed. I have to say, because we have been building so much and doing so much, not all of this is yet published, but we're right now in the process of working hard on publishing many of those things we did. It supports an iterative process, so you can basically have people submit their solutions via the platform in multiple stages. So this is an example from a hack where the people had to submit at certain milestones after each phases. After each phase they had to submit, and then basically there's a stage. In between, they can work as much as they want. They can also submit, and we can offer interim solutions, evaluation opportunities, and where they get scored. So it's in the end, you could argue it's not necessarily fully synchronous. It's not necessarily a game where one plays against past participants. It is really a contest at this point, the way you implement it. Games is a game feature we're working on. After each round, right now we have real-time scoring, so it's then immediately available. And this would also then have rolling data access. I'll talk about this in a little bit more. What are the key features of the platform? You have a fully supported workflow in working on data science. You had an iterative submission process. You can add, you have multiple submissions that allows then for repeated measures in terms of your experimental design You have a real-time dashboard and scoring that allows people to see how they do, and also for the researcher allows them to change what they show and toggle it on and off. And you can use also, we offer social solution sharing and social interaction indirectly at this point. We work with acronyms, so not real names, just to control for any other kind of social influence. The key feature for the user really is the data science workshop space, the Jupyter Lab, and the secure big data query integration and pre-processed data sets and very specific tutorials that help people to be onboarded. We specifically develop them over time. So as I mentioned, Jupyter Hub, Jupyter Lab, you might know it, you might use it yourself, you might run Jupyter notebooks all the time. We basically run it in a cloud. And then the BigQuery integration, which is a flagship data warehousing tool that is there to be used. So if you have big data sets to be used, if you want to have like a structured data set that people can use. And it's also for participants an interesting motivation. We have the full integration. So for example, we worked on data from SafeGraph, provider for the White House as well during the pandemic, that had all the social distancing data using mobile phones, millions of mobile phones in the United States, gave us the data. Others we work with in the workforce development. Then we have an automatic pipeline here to bring the data into our BigQuery table, and then from there participants easily access it after authentication. They don't actually have to interface with BigQuery at all. They can just use it through the notebook, and we have a tutorial how to do that. We have partners. I'm not going to talk about this given time constraints. The architecture is state-of-the-art. React.js is Firebase. We do have Kubernetes, meaning people can use GPUs and run also deep learning models at this point. And we use here our internal resources for this, and gives them flexibility. And what happens is they all run their own kind of notebook in a container, which then gives us the ability to collect all their history on what they're doing, which then can be analyzed for people that really like to analyze trace data. You have really rich trace data. I have to say this up front, you will not get that if you work with Kaggle, where you only get the submissions. So that's kind of the kind of overarching simple architecture. Now, let me talk about two examples that we think helps to understand how we use the platform for research. So these studies are focused on information disclosure and transparency. One was on the effect of performance and solution transparency on innovation and web development contests. And the other one focused on abstraction of solution transparency in data science contests. I'm not going to talk through this like an academic paper. I rather want to show how we use that platform to set up the treatments. So first of all, this platform actually uses the IronHacks 2.0 that I'm not going to demo at the end if it all works out. This used the prior version, but the ongoing experiment very much built upon that and continue that stream of base threads. So there the participants had to develop a web application, a mashup that meshed up different open data from the data.gov. We all controlled how many, what they could use. We checked on that. And they had to basically support users in finding a safe, affordable place to use at a particular point on the map. The mashup had to have 3 components. And the app should help the users to find the optimal location. So we could also actually evaluate and judge it based on that. We did at that time. We had experts checking it. We ran some scripts, yes, but it was not automated at this point. We also had minimal technical user requirements. The workspace was here an interactive cloud-based editor that was focused on HTML, where you could in real time make edits to the code, and then you could load your website and you can see your mashups and so on. A mashup, again, you have a map, you have interactive charts, or sometimes you have these overlays on a map, and you have user input. I'm sharing a screenshot on it in a little. I don't have time to demo it in detail. We had GitHub integration. What it actually did is, with this kind of integrated cloud-based editor, it allowed individuals to search across a visual and a structural landscape. So they could see what the app looks like, but they could also see how it was built, so they could actually look into the code. And so that's an important aspect, how it then affects search and problem solving. Individuals worked individually, but after a certain submission deadline, they had the opportunity to examine other solutions, depending really on the treatment we used. It's kind of an oscillating search process, as I would argue, and also this is how I write that in the paper. So the process was 5 submission rounds with immediate scoring. All scoring after each round, they had a personal and a public dashboard. Then after its evaluation, treatment conditions defined what they saw. And if so, it's a kind of somewhat asynchronous process. We used a 2-dimensional evaluation, technical performance scores, software defects, maintainability, fulfillment of technical requirements. We ran scripts on that, all based on software engineering literature, etc., all backed up, since my team and I have a deep understanding of that literature as well. And then we also looked at the functional performance scores, here also inspired by research on usability and innovation. We looked at user requirements, information visualization, and psychological novelty. The evaluation was done at this point by trained experts. Some were programmers, just were visualization experts, and they were all trained before, and we made sure that they had a high inter-rater reliability. And so it's a combination of audits, computational scoring tools, I should say, and experts. Here again, quick screenshot on the editor. We don't have that platform hosted at this point, so that's why I have a screenshot here. You see, you have the code here, the web, here's the code. You see that here. I should have properly used maybe at and then at the same time you could run the app, and then you would see actually the app. Here's a sample app of that you could also, if you want, look at afterwards. There's a YouTube video link. I'm sharing also the slides afterwards, and you can explore it. Yeah. So what was the motivation of that study? The study basically was motivated by the fact that in the literature there's a theoretical hiccup essentially about the effect of transparency, as I call it, or information disclosure, as I also call it. Here, transparency is about sharing collective information. And one, that it's argued that transparency increases novelty and performance via a combination of risk-closed solution and direct social influence. There are various different theoretical perspectives, and others say no, it leads to convergence, or it leads individuals to cognitively fixate, and that's why it would potentially lower the solution's novelty and performance. And so in that study, I propose that the existing work does not sufficiently distinguish between the effect of 2 complementary transparency mechanisms that are essential for the search across the landscape. So it's performance transparency, like what the value is of the solution, and the solution transparency, the way the solution is built, leads to the research question: what is the individual and joint effect of performance and solution transparency on innovation search? And we measure innovation in different ways. Relational novelty, we look at distance of search, and also performance. I'll talk about that. So the kind of idea behind is that solution information, and here again they had access to the user-facing functionality, what the design does, and the structure, how it was built, defined basically as the visibility about others' innovation is solved, enables reuse, recombination, and shapes an individual's mental search space via social search. And performance information, on the other hand, defined as the visibility of performance of other solutions compared to other ones, triggers experimentation through and risk-taking through social aspiration. So in the end, it affects the search across the landscape, like the environment in which problem solving takes place. And in some of our treatments, that landscape is basically socially moderated and is evolving because you see other solutions. The performance peak in this case externally defined because you know what the best solution is, but the people do not know that before because it's more a wicked problem context. Searchers create new alternatives through the recommendation of choice variables. In this case, it's the source functions that they recombine, and they can also explore the functions of others. So in the source code, the functions. Exploration here is really defined as systems related to past search. And novelty is a relation context, so in relation to others in the in the space. So it's relation construct based on psychological literature. We've used 4 treatment conditions. So on the one hand, we had no transparency. So that's when they did not see anything at all. That's up here. They saw only their personal dashboard, and that was kind of the default. Then we had one about performance transparency. You see that here. So you saw other hackers. We didn't share names or anything. We didn't want to do that. They saw the total scores, and then they could toggle back and forth, which gives us, then they saw the details. By the way, it gives us access to click data that we store if someone is interested in the end, examining their behavior and looking at others' content. We store all that information. We have that all in our database. Solution transparency, on the other hand, shows other solution. So you have the hackers again, and you just have names here. We didn't use acronyms. We're using this today. And then you could click on a project, and you would see the running app. You don't have to do anything yourself. You know, typically, if you get source code, you have to install it, run it, host it, etc. That's all there. We basically hosted everything for them. They could look at just the running app, but if they wanted, they could also look at the source code and explore, you know, their file structure, etc. So we provided all that, and there was no effort actually needed from their side, which is very unique at that point, I would say, but it's an interesting thing to study transparency effects. And we randomly assigned them to 265 software developers. The hypothesis really was that, you know, the combined effect increases relational novelty, exploration, and innovation performance. In the end, we had like 825 apps collected throughout the 5 years. They're all submitted in all rounds, more than 165 source code functions, and 400 lines of code. The measures independent was the treatment conditions and control variables, and the dependent variables distance of search, relational novelty, innovation performance. Methods here, we used the computational method for functional extraction. More details to be shared, and then regressions and so on. At this point, we're in the process of publishing that work. Here, just example here, you see all of it's a repeated measurement design. You see that over time, basically full transparency had the highest individual exploration, has the highest performance, and also the highest relationality. Meaning, unlike as others would have expected, it doesn't lead to convergence. It's still the highest. It performs the highest. So it does not lead to the convergence, even though you would potentially think it would do. So it continuously triggers exploration and deviation from others because of the performance information. What's interesting also is we did an examination. I'm sharing that at this point, that the distance from the best is not necessarily a good predictor for how much they try to diverge. We also here want to show just a quick MDS, multidimensional scaling, that you see that in the full transparency it's less clustered, that's only lightly clustered, compared to the no transparency condition. Here on the right hand side, here on the left hand side is a full transparency condition. So that kind of gives a bit of an insight here. Another study that we just actually completed the data collection, honestly speaking. As of a few days ago, we haven't even finished pulling all the data to analyze them. I just wanted to share it because it's related to that, and it is based on the most recent platform. It's the abstraction of solution. So these tasks that we're running now is really prediction tasks, and they're interesting for the participants, particularly about forecasting, and if you give them kind of rolling data. And they were also really important during the COVID-19 time, and that's when we started building these prediction tasks and work with safe graphs, etc. The task here was, for example, predicting unemployment claims in the state of Indiana. That's the task I shared. Work with Indiana University. Here we had a ground truth solution that was not revealed. They didn't have access to that. The Jupyter Lab is hosted in a Kubernetes service. They have immediate access, no cost for them at all, no access needed. They can just load it. There's an autosave features. They never lose their work, and we support multiple languages. And I wanted to mention they have GPU. They can also run really a lot of different models. It's actually very interesting because they try so many different models, and it's very exciting. Here the task, and here the kind of the workspace. Process here was multi-staged. Again, there was basically not every submission was mandatory, only certain were mandatory, and they then could make interim submission to get real-time feedback. And again, they had a personal dashboard, and then we also showed the peers. Here, the two-dimensional scoring was the prediction accuracy, MSP and MAP. Classic was used on Kaggle as well, and then we also had some exploration scores at this point. Sure, I forgot to mention, we also had prize awards. We modeled this just after past studies, exactly the same. We had kind of a rank ordered incentives. That's not a treatment condition. That can certainly be changed. We did not look at that. So here again, I think the treatment would be interesting for you to know. So on the one end, we basically, when they went to the results page, and you see that here, there has one treatment that has like in the end full solution information in that sense. So there you have your peers tab, and then you see again, transparency means collective information, those of others. You could basically see the summary of other submissions. So here we work with acronyms. These are not real names. And then you can look at the summary, click on it, and can read it. So we gave them guideline how to write that. So in that summary, they were asked to provide a summary of their model, the statistical model that they were using when they're saying they were using a random forest, and they were using CNN, or they were saying I'm just using an ARIMA, etc., to explain that. And then also about the actual procedure without sharing any kind of information about the code itself. There was not the implementation was not there. And then we had another treatment where they had only the notebooks. So basically what they were able to see their peers, and then they were able to click on that link, and then they were able to see others' notebooks. I hope I have time to demo that later. I just wanted to show that also on the slides. You have flexibility in how you use my recorded session, so whatever you want to show on this recording and the live demo later. So in that study, that was actually designed with collaborators from other universities in New York, and the motivation was to study abstraction. The abstraction of information and construal theory was used to kind of theorize, to develop the kind of the higher level research questions, also hypotheses, because that theory proposes that the psychological distance between the perceiver and the target determines whether the perceiver adopts an abstract or concrete mental representation. Oh, I see there's typos in here. High level construals, like the general abstract level kind of features of something, and focuses on ends and desirability. So it's basically the why and how, and then the lower level is more the how aspect of actions. So the research question was, how does abstraction of solution information affect search and innovation in solution space? Okay, I end here. I just want to also conclude that the features, the benefits for the researchers of others. So we are really now in the process of opening it up, giving people admin accounts, working on specific hack organizer accounts, onboarding materials, or at this point often it will be more collaborative. And I'm looking really for collaborators that want to work with me, just because it is so hard to build these Kaggle style platform. It costs a lot of money, and not just that, but it's also something where I would like to collaborate with people and give them the opportunity to use it as well for the experiments if they're interested. And so we built it that someone who's not a heavy coder, also from a back end, could just modify things, toggle on off features. And so you can decide a little bit about the randomization, the purpose of sampling, because we have whitelists that you can upload if you want yourself, or you have multiple ways to do your treatment designs at this point with respect to the task, with the incentive, but in particular also what information is shared, whether you want to use groups or not, and how many. You can also change this on off. That's all through a user interface. You don't actually have to be a programmer. You have a survey integration there as well. There's a Qualtrics integration at this point. You can use synchronous or asynchronous processes. You can use our pre-developed scoring script if you want. You can use your own scoring script if you're not happy with it. You can just download the solution and then just manually add it if you want to. You also have a lot of rich data collection. That's what's on this slide. You not just have surveys. It's on the top. I think it's not the most interesting one. You have a workspace. So you have not just a submission, you basically see every single kind of cell that is executed by a participant in the cloud, and we store that. You have that sequence information, and you also do have the ability to connect that with timestamps. So if you're interested in time series modeling, if you want to do that on the source code, you can do that, or the commit level analysis. There is nothing out there that I know if you use Kaggle that you have that. And you might not need it for your research, but I'm sharing that you can do it. You have the submission notebooks, you have summaries if you provide that. You have the forum posts, you have the user data, you have the email threads from our email integration mass being. You have click data, and you also do have notebook analysis at this point. Yeah, this is an example of a history in the workspace of a participant on the different commands and functions she was running over time, showing that color coding is basically how she's adding basically to a cell or a function. We extracted at this point here with regular expression and some other computational techniques, natural language processing, and you see how that basically over time you see what's in the first submission and what does not make it into a first submission. So here you see everything that's red, and then you have that line here. You see everything that made it into the first submission, and basically what's blue is basically what you did not in the submission and what she then shared and uploaded. So what's basically held back because you basically did search locally without sharing it with others in the submission phase. So that gives rich information that you could use if you want to explore like individual search versus basically search that is shared in the collective space. We advance the system at this point of time with recommender systems. So here, for example, right now one of my students is working on a thesis to integrate recommender for Stack Overflow that, for example, then provides top Stack Overflow post related to an error. It's in the early stages, but that's what we're doing because we're interested primarily here at the center also in AI features. So we're adding more of that. You can already at this point, use some simple AI algorithms without the problems, but this is going to be more advanced one. The server integration we're thinking about our old survey tool potentially because of Qualtrics, not everybody might use it. Maybe improving also the Jupyter Hub integration, a little profile enhancement. And so this is on our list of change requests. And there are people, it's open source software. I need to say that our platform is open source. Are more than invited to collaborate with us if they want to and work with us. Yeah. Here's some related publications that are there related to prior versions of the platform. Something is published, in MISQ or JSIS, none in the management discipline, and there's other ongoing work that we are right now preparing for submission in management science. So I'm more than happy also to share more info here. Here, info to the app. So our source code is open source. You see that on GitHub. The docs is also there. If you want to submit an issue and want to change, you can do that. Then we also have, a blog. You can contact me via our general email, opendigital@purdue.edu. And on our web page, we do have a donation page. If people say they want to donate, I'm saying that because it's been a bit of an effort here. This has not been just developed by students or master or PhD students or postdocs. There have been professional software developers that have been working on building the platform in collaboration with students that did that. Okay, now I'm at the end, and I think I recorded way too much time. I'm now giving a quick demo if that is possible this time, and I'll be jumping over to the actual site. So here you are on our landing site with information about it that I just discussed, but I think you have the ability to explore that yourself. And at the bottom we do also have, I mentioned, the donate button. And so I'm now going to sign in here with my account very easily with Google. So now I'm going to, so here you have an overview of hacks that we loaded, that we've been running. We have been also removing hacks. So this is one hack, that the one that I just talked about. And this is the one that I'm going to, somehow my social feed is right now not loading. I guess it's because I'm using so much from my browser right now. So here I'm basically on the landing page. This gives an overview. And that's the first thing they're going to look. They get all the details they need about the hack, the registration, the deadlines, and the summary. I'm most likely scrolling too fast. The key feature is for search, for understanding search and problem solving, is the workspace. I'm going to open this here right now. I had opened it already before just to kind of prepare this a little. It's the classical Jupyter lab. And in there, I just loaded a notebook for you. This is a notebook, you know, and it's a Python notebook. I'm scrolling here very fast, where we did some analysis actually on the data. Some of these cells are already run. I'm just scrolling down to one that is not yet executed, potentially, hopefully. Let me clear the output. And as you know, notebooks, you know, in the end, so to speak, you can basically run the notebook in the cloud. You can do this, and we also, this is the way the people would work. They would write their code, etc. I'm not going to give you now a coding lesson, but I just wanted to show you it's the full-fledged code editor, where we have a very simple authentication process at this point. Okay, let me go back to the main page. So I think what people want to know is about the task. So here's then the task page. You would have to get the task at this point. I have not gotten the task at this point. You have an example page, and this is already where you see these are examples that we preloaded for the participants on linear regression, ARIMA, exposed random forest, and so on. The reason why is we want to make sure that everybody kind of starts off with the same information at this point. They can expand and provide that, and they can also look at the notebook viewer. We have a forum that we also use for people for making announcements. We are not necessarily at this point using this very actively for communication. It's more for us to use. It's more like an announcement board for people than to respond to that. You could technically build subgroups and allow group communication among us. We have not been using this. It was you have an overall kind of forum, but there's also the ability to build forums within groups. And when people then have worked on this, most likely they will be using tutorials because these tutorials help them. So these are tutorials we built in Introduction to Jupyter Notebook. We have a tutorial on SQL. We have a tutorial on BigQuery. We will make sure that everybody has the ability to quickly perform that. These tutorials are run by my team at this point. We also built basically the first basic regression. So with that, you can basically modify your experiment in terms of what are they having access to. Then here is the submission page. So I could then, when I have prepared my notebook or have my solution, I could pick a solution, go in there. And then, we have the full description of that. We have, clarifies, very similar to Kaggle, what they need to provide. So we ask also for a CSV file. We ask for a Python notebook. We ask for a model summary, link to the tutorial, what they have to do. Tell them also how they should provide references in the end. And then I could do that. So in the end, what we also basically do is tags. We get that, and we do have the ability for them to reference peers, with this giving us the ability to capture whether they're purposely referencing someone or not. We do run code cloners also in the back end, so it's not necessarily just that way of seeing what they're doing. This gives us ability then to flag items. It can also be used for research. In the end, what I would be doing at the end here is up basically a drop here file, and then I would be submitting. And that's my basically notebook. The most important feature I think right now for our experience was the result page. And so here I'm actually an admin user at this point. So that's why I basically can have the ability to pick a user and see its results. Takes a bit of time to load. So you see, MSP, MAP, expiration effort, and then we have a description of that. And then I can toggle to my peers, and you see I'm in a treatment right now where I do have both. I do have the summary of the submissions, and I also have the notebooks of the submission here for that person, Tranquil. It's an acronym. I can look at the summary. That wasn't too long. Got us as well. And I can also open the notebook viewer. And then show the notebook. Taking a bit of time. I have to say that because I'm screen recording, there's also a lot of right now going on in my browser. So that I'm recording screens with two screen recorders, so it's too much for my Chrome browser right now at this point. So what I'm going to ask here right now is Menthan at this point, who's also with me here, to change the treatment condition so that I could reload the page and show what it would look like for someone else.
Okay, will do. Okay, I changed the setting from the admin.
Let me select the user. Again, I have my scores. And at this point, I wouldn't see the summaries. The only thing I could do is I could click on this. I could give it another try. I'm really already taking a lot of time for the recording. But basically what I could do is I see the notebooks, and we have our own integrated notebook viewer that you can then use. I may try it again if it doesn't work because I'm using too much of... Yeah, so now it's loading. So here you see the notebook. They could look at it. So this way, they're not executable. I wanted to mention this. They can look at it. However, they can also download it. And with the ability here to click on download, you have another click data that you can use for your research to see whether they're actually engaging in that action in case you want to. Otherwise, you would just have them view it, which is a different way of basically searching across the solution space. So yeah, that's why we built this kind of viewer, because it's not actually executable. You can basically see whether people view, and then they could, if you download it and we find it back in their workspace, you can actually then capture the information that they actually run it and engage and trial and error learning, as you would argue. Okay, so having shown you that, I'm going to quickly also go to the admin side panel here at this point. On the admin panel, I just wanted to show you, the reason why I'm showing this to you is because it gives you an ability to see how this is all set up for people that want to use it. In many cases, if you would be working with us, we would be doing it for you, but it would also, I would more than happy to share and have you do that. So you can tag along things on off and say, I want it, I don't want it. You have full flexibility in changing. You have the ability to integrate surveys here with links, very easy. You can build your cohorts here at this point. For each cohort, you can pick a task, and you can have multiple tasks. You can enable in forum, show notebooks, etc. Here you see already kind of the random assignment. If you do the random assignment feature, like if you click as a random assignment, you could do that. But we also have the ability in the registration here. Through the registration, we can upload whitelists, and through the whitelists, you can then specify basically who you want to have in there or not. You can also basically download the report. So again, it's loading, it's taking a bit of time to load. Yeah, so you can basically remove, but you could also, use a whitelist for upload. Overview, yes, so this is the overview page that you see. We use Markdown as an editor. So you have Markdown is also actually what you use in Kaggle. So it's a very simple markup language, or it's easier than HTML. It's a very simple way of editing text in terms of the way it is presented. And you can always immediately see the live document. Here's the result page. And you see here are the results that we created. This is a way for you to create the dashboards here to show what is visible. And then also what you can do is, you can publish or not publish submissions. You can modify what is shown as results. This is automatically preloaded through our scripts. So you calc MSP and so on, expiration efforts, that's done through our scripting tools that run through a cloud function in our cloud. And you can validate it yourself. You can manually change it. If you don't want to use this, if you just want to change completely what is shown to the participants, the only thing you have to do, you have to upload basically a JSON file that follows that structure with the user ID, and you get that from the download. This is a Yule rules page. This is basically the way you can build as many submissions as you want. You can edit it, you can enable it and delete it. And again, you have survey integration. If you want to do a survey, I should have shown a survey, I forgot. You can say, I want summaries, I want text, I want references. You can add additional things that they should upload as much as they want. And maybe the most interesting feature, you can attach a ground truth information if you want to at this point, because then this is automatically used for scoring. We use this for our mean squared error, mean absolute error. Task, tutorials. I forgot to mention that. Task, you can add multiple tasks. Tutorials, you can build the examples page. You can also build banners, and we have additional extensions that you can use. Yeah, so that's it. I would like to thank everybody for listening to my presentation. At this point, I would like to kind of go back to my slides and hopefully have a final image here. And would like to thank everybody for paying attention to my presentation. And unfortunately, I'm not there, but I'm giving a virtual half-an-hour session tomorrow, and I know I've run over much in terms of time. But you can decide how much you show of my recording and cut off after 25 minutes. And maybe others want to watch it on their own.